Welcome to the deep dive. We're about to embark on, well, a pretty essential exploration today. Because artificial intelligence, AI, it isn't just some buzzword anymore, is it? It's rapidly weaving itself into the very fabric of our businesses, our daily lives even. And yeah, it brings incredible innovation, truly transformative capabilities, think streamlining complex operations, unlocking insights we never had before. But, and this is the big but, alongside that huge potential, AI also ushers in a whole new set of complex and, let's be honest, often really intricate risks. It's no longer just about your internal systems, how you are using AI. It's about understanding who you partner with, how their AI works, and even the tiny components that build it, right down to the silicon. So today we're taking a deep dive into this fascinating, sometimes bewildering world of AI vendor and supply chain management. Think of us as your guides. There's some pretty critical material here. We'll be unpacking Chapter 2, Part C of the AAISM Official Review Manual, that's the Association for Artificial Intelligence, in Security Management, a really foundational resource if you're working in this space. And then we'll put that knowledge to the test. We've got a real-world case study that really illustrates these concepts in action, helping us bridge that gap between, theory and the practical side. Our mission today is to equip you with the essential knowledge to navigate this evolving landscape of AI in the supply chain. We want to make sure you're well informed on what's important and, crucially, why it really matters for your organization's future.
It's truly fascinating, and I think often overlooked, is that AI doesn't just add new layers of risk on top of what we already know. It fundamentally changes the nature of risk itself. Those traditional risk management frameworks, the ones organizations have relied on for decades, they need to adapt dramatically, actually, for AI. We're not just worried about systems going down or data breaches in the way we used to think about them. Now we're grappling with really unique challenges, things like algorithmic bias, right? Where an AI system might unfairly discriminate simply because of flaws in its training data. Even if the system is technically up and running perfectly fine, it forces us to redefine what working correctly even means in this age of AI. So it's no longer just about assessing a vendor's general security posture like you would for a standard IT service provider. Now it's about understanding the deep, nuanced intricacies of their AI models, everything from the provenance, the origin, and the quality of their training data, right through to the ethical implications of how their AI makes decisions. And this raises a really important question, doesn't it? How do organizations effectively balance the immense, honestly, game-changing opportunities AI offers, revolutionizing your productivity, efficiency, with the unique, often unpredictable vulnerabilities it introduces across its entire complex lifecycle? It's a delicate balance, continuous balancing act, really.
That's the core challenge, exactly. It sounds like we're not just adding new tools to the toolbox, but we're fundamentally rethinking our whole approach to risk. So, to really get our heads around this, let's unpack where AI is fitting into the grand scheme of things. Our source material, the manual, it starts by emphasizing how deeply AI is becoming embedded. We're talking critical infrastructures, core business operations. It's becoming indispensable. What's the big picture here when we talk about enterprises and their evolving role in this whole AI supply chain?
Yeah, when we connect this to the broader landscape, AI presents this powerful, almost paradoxical duality for organizations. It's fascinating. On one hand, it offers a really undeniable pathway to significantly boosting productivity, enhancing operational efficiency, and just sharpening overall competitiveness. I mean, imagine a manufacturing plant using AI for predictive maintenance. It anticipates equipment failures before they happen. That drastically cuts downtime, saves potentially millions. Or think about a retail company leveraging AI to personalize customer experiences in real time. That could lead to increased sales, better loyalty. AI can optimize incredibly complex supply chains. It can accelerate scientific discovery in areas like drug development. It can even automate mundane tasks, freeing up human workers for more strategic stuff.
Yeah,
It really is a force multiplier. It can redefine what's possible for a business.
they're
There's
both
always a
both.
but, right? On the other hand, this deep integration comes with a unique and often far more complex set of risks. Risks that go way beyond what we typically see in traditional IT. We're talking about the potential for malicious misuse of AI systems. Think about the rise of deep fakes. AI-generated content used for fraud or disinformation, or even autonomous systems being weaponized. Then you have the inherent vulnerabilities within the AI models themselves. Beyond algorithmic bias, which we touched on, there's stuff like data poisoning. That's where bad actors subtly corrupt the training data to manipulate how the AI behaves later on. Or model drift, where an AI's performance just degrades over time because the real-world data it starts seeing is different from its original training data. And of course, there are the inevitable human errors, people interacting with AI, configuring it, maybe just misinterpreting the outputs. The sheer scale, the speed, the complexity of these AI systems mean that even tiny errors can have these huge cascading impacts that are really difficult to trace and fix. It truly is a double-edged sword.
You've mentioned risks that stretch beyond just the technical side, like concerns around authenticity, with creative AI, or even the societal impact like job displacement. Can you elaborate a bit on that societal dimension? It feels like a really human element woven into all this tech talk.
Absolutely, and it's crucial we don't lose sight of that. The manual highlights that AI's capabilities are now extending into generating new forms of art, music, literature, which is undeniably incredible. You can open up entirely new creative avenues. But at the same time, it raises these pretty profound concerns about the authenticity of these AI creations. Are they truly original? Or do they just mimic and remix existing human works without any real understanding? Does it dilute what we think of as traditional human expression? Or does it push the boundaries? Does it challenge our very definitions of creativity, of authorship? These aren't just philosophical questions anymore. They have significant cultural, economic, ethical implications for artists, for industries, impacting things like copyright, intellectual property. And from an organizational perspective, yes, AI certainly offers opportunities for career growth. It demands new skills, AI development, maintenance, oversight. It could lead to big upskilling initiatives. But there's also that legitimate fear of job displacement. As AI automates more routine or predictable tasks, certain roles might shrink or transform entirely. That means organizations need to think really carefully about reskilling programs, about managing workforce transitions thoughtfully. And furthermore, a critical, often subtle risk is algorithmic discrimination. If AI models are trained on biased data, say, historical hiring data that favored certain groups, or they're designed with flawed assumptions, they can perpetuate and even amplify existing societal biases. This can disproportionately affect certain demographic groups in hiring, lending, access to healthcare, even criminal justice. So this makes due diligence in selecting your AI provider and then continuously monitoring that AI not just good business practice. It's a crucial ethical and social imperative. Organizations have to actively work to identify and mitigate these biases to make sure the outcomes are fair and equitable.
Right. So it's about being proactive, not just reactive. To help us sort of categorize and understand these evolving AI threats, our source material offers a really insightful framework. You called it a threat map earlier, which I like. It helps visualize these diverse risks more concretely. It's called the AI threat conceptualization example. Can you walk us through that? How does it help make these abstract risks more tangible for, practitioners?
Yeah, threat map is a good way to think about it. This framework uh, it provides a powerful and pretty comprehensive visual guide for understanding AI threats. It breaks them down across various dimensions. What it does is help organizations pinpoint more precisely where and how vulnerabilities might pop up within their complex AI ecosystem. And that allows for more targeted, more effective mitigation strategies. So first, it categorizes threats by the actor involved. Who's causing the potential problem? You've got end users. These are folks who might unintentionally misuse an AI system. Maybe they enter poorly phrased prompts or even malicious ones into a large language model, or they just misinterpret the AI's output, leading to bad decisions. Then there are the providers. They could intentionally or unintentionally introduce fundamental vulnerabilities during the AI's development or deployment, maybe through insecure coding, maybe using compromised training data. And finally, you have the bad actors. These are the people actively seeking to exploit AI systems for malicious purposes, intellectual property theft, system disruption, using generative AI to create convincing, fraudulent content like deepfakes or phishing emails. Okay, so beyond the actors, the framework distinguishes between the types of threats. Abuse that's using AI for harmful purposes, like generating misinformation. Deny, preventing legitimate access or functionality, basically a denial of service attack but aimed at AI capabilities. Steal, getting sensitive data or the proprietary AI models themselves. It also characterizes threats based on the inherent characteristics of the AI system itself. Is the system inefficient? Is it consuming excessive resources? Is it unstable in its performance, leading to unpredictable outputs? Or are its outputs maybe biased, toxic, or even fake, especially with generative AI, creating content that's discriminatory, harmful, or just completely made up? This goes beyond typical cybersecurity threats, right? It considers the unique operational and ethical nature of AI. On the diagram, it further contextualizes these threats by showing their origin within the AI lifecycle. Where do the problems start? Did it happen during production? Maybe during deployment or ongoing operation, perhaps due to misconfigurations? Or did it originate back in development? Like during model training, maybe biased data was used accidentally. Or during the architecture design, maybe security vulnerabilities were just baked in from the start. It also differentiates the human element. Was it intentional, malicious action by an insider? Was it an unintentional error made despite best efforts? Or was it negligent human mistakes, or maybe proper procedures weren't followed? And lastly, it points to technical root causes like misconfigured security settings or using outdated components in the AI infrastructure that could be exploited. This comprehensive, multidimensional view really helps you understand how all these potential failure points are interconnected and where you need to focus your defensive efforts.
That's incredibly helpful for structuring the thinking. So, if AI is becoming so deeply integrated, everywhere, how do we actually manage the vendors who supply these AI solutions? It really sounds like traditional vendor management, the stuff we've done for years with IT services, just isn't quite enough to handle this new layer of complexity AI brings. Is that fair?
That's exactly right. You've hit on a really crucial point, one that, frankly, many organizations are still grappling with. Existing vendor management programs, they absolutely need to be reviewed and significantly updated to account for the unique characteristics and the inherent risks that AI introduces. It's not just about adding a few new questions to a checklist. Not at all. Many vendors now embed sophisticated AI features directly into their services. Think advanced analytics tools shaping critical business decisions or automated customer support systems handling sensitive stuff. This introduces a whole new layer of risk right alongside the undeniable increases in productivity they promise. The key here isn't just reacting when something goes wrong. It's about applying proactive due diligence from the very beginning, understanding the AI's core mechanics, its limitations, before you even integrate it. And this is exactly why transparency from the vendor and having robust assurance mechanisms aren't just nice to haves. They're absolutely vital for managing these AI-related risks effectively.
Okay, so what are the specific, maybe new considerations organizations really need to keep top of mind when they're vetting an AI vendor, especially when looking beyond those standard financial and security checks we're all kind of used to doing?
Right, when considering an AI vendor, you absolutely need to expand your scope. Go beyond the standard traditional checks that are part of conventional vendor management. Our source material highlights several critical factors. Some are new, some are just significantly amplified because it's AI. First off, the financial instability of the vendor. Can they genuinely sustain ongoing support and development for their AI solution long term? AI models aren't static, right? They need continuous refinement, updates, significant computational resources. Just think about the power needed for these large language models. So, a financially shaky vendor, that's a major red flag. You could end up with an unsupported, rapidly aging AI solution down the line. Second, lack of insurance, specifically tailored for AI-related incidents. Are they adequately covered for potential liabilities, things arising from algorithmic errors, biases, security breaches specific to their AI? Traditional cyber insurance often has gaps here, so ensuring they have the right coverage is crucial for risk transfer. Then there are poor security practices. Do the security controls meet your standards, especially concerning the security of their AI models and the sensitive data used for training and running the AI? This goes way beyond basic network security. It includes things like secure development lifecycles for AI, robust access controls for the models to prevent unauthorized access or tampering, and protection against advanced adversarial attacks designed to trick or corrupt the AI. Reputational risk is another huge one. What's their track record? Have they had issues with AI ethics, past bias incidents, previous AI failures? A vendor with a poor ethical history or public AI missteps can seriously damage your own organization's brand and trust with your customers. We also need to assess their operational resilience, or lack thereof. Can they recover quickly and effectively if their AI has disruptions, model failures, or significant data breaches? Given how deeply AI can be embedded in critical business processes, imagine an AI-driven fraud detection system failing the ability to rapidly restore service and data integrity is just paramount. And finally, supply chain issues within their own AI supply chain. Do they understand and manage the risks from their sub-processors, data providers, model developers? The AI ecosystem is incredibly complex. A vulnerability deep within their supply chain can easily become your vulnerability. It creates a potential domino effect. But perhaps the most crucial factor, and one that's often overlooked in traditional vendor assessments, is the lack of transparency and explainability in the AI model itself. This is the black box problem we keep mentioning. If you, as the organization buying the AI, cannot understand how it makes its decisions, how it gets to its outputs, or the specific data it was trained on, that creates a significant risk. This opacity makes it incredibly difficult to assess for hidden biases, ensure compliance with regulations, debug issues when they pop up, or even truly trust the AI's recommendations. So managers must ensure that vendors don't just promise strong security, compliance, privacy, and robust controls tailored for AI. They have to be able to demonstrate it. This means setting up robust protocols, getting your legal, compliance, privacy, and security teams collaborating effectively right from the start of the vendor selection process. Make sure every angle is covered.
That really sounds like a multidisciplinary effort is needed. And our source material, it also provides a very detailed flow, almost a blueprint, for an approach to artificial intelligence vendor management. It breaks it down into clear steps. Could you walk us through those key steps, explain their significance, help us understand how to move from this theory to actually implementing it?
Absolutely. This blueprint, it lays out a systematic, robust approach to AI vendor management. It moves beyond just ad hoc checks. It's specifically designed to reduce organizational risk throughout the entire vendor vetting and lifecycle process. Okay, so it starts with defining internal diligence and need for AI. Before you even look outwards at potential vendors, you, the organization, must clearly understand your own specific AI needs. What are your strategic goals for using AI? What's the potential impact, good and bad, on your operations, your stakeholders? It's about defining your requirements first. That lays the groundwork for effective vendor selection. Next, you need to create an AI vendor inventory. And this isn't just a simple spreadsheet. It's about compiling a comprehensive list of all your current and potential AI vendors, along with the specific AI solutions they offer. This gives you crucial visibility into your entire AI ecosystem, letting you manage relationships and potential interdependencies much more effectively. The third critical step is to adapt existing due diligence to include AI-specific risk assessments. This is where you significantly modify your traditional vendor assessment processes. You need to specifically address the unique risks of AI. So, for example, instead of just asking about general data security, you'll dig into questions about data provenance. Where did their training data really come from? What are their model bias testing methods? How do they ensure model explainability? It's not just adding a checkbox, it's fundamentally reevaluating the risk framework. Following that, you evaluate vendor reputation and financial stability. This is standard, yes, but it's amplified in the AI context. You need to ensure the vendor is reputable, has a strong market standing, and is financially sound, capable of providing sustained support for complex AI solutions that need ongoing maintenance and updates. A struggling vendor, that just means future headaches for you. In parallel, and this is crucial, you assess vendor practices, policies, and alignment. This digs much deeper into how the vendor actually develops, deploys, and manages their AI. Do their ethical guidelines, their data privacy practices, especially around sensitive personal data used for training, and their security policies align with your organization's own values. Your regulatory requirements. This is vital for areas like responsible AI principles and data governance. And here's where it gets really interesting, almost transformative. You then define your risk appetite for AI system instrumentation and its use, misuse, and abuse. This isn't just about identifying risks. It's about formally setting acceptable limits for risk exposure related to how the AI system will be used, its potential for unintended consequences, even deliberate misuse. For example, are you okay with a certain percentage of false positives from a fraud detection AI if the benefits outweigh that? It's about deciding what level of risk your organization is willing to tolerate for the benefits AI provides. This is a critical strategic decision that drives all subsequent controls. Okay, so after establishing your risk appetite, you establish compliance and incident notification criteria specific to AI. This means setting clear expectations. How will the vendor comply with AI-specific regulations like the EU's AI Act or data protection laws like GDPR, which now cover AI decisions? And critically, how will they promptly notify you of AI-related incidents, including things like model performance degradation, data integrity issues, or even adversarial attacks? Then, you develop practices for routine monitoring and reassessment. AI models are dynamic. They can drift over time. Their performance degrades. New biases can emerge because real-world data changes. So continuous monitoring of the vendor's AI performance, their security posture, their compliance, it's essential. Not just a one-time check during onboarding. This might involve setting up automated alerts if the AI starts behaving unexpectedly. Finally, you establish triggers for when a full risk assessment is needed again. This acknowledges that the AI landscape is incredibly dynamic. Things change fast. Triggers could include significant model updates from the vendor, changes in relevant regulations, the emergence of new types of adversarial attacks, or even major shifts in your own organization's risk appetite or strategy. This iterative process is absolutely vital for dynamic AI systems. It ensures your risk management posture evolves as the AI systems themselves do. It's about building a continuous feedback loop into your vendor management strategy. ongoing vigilance.
That is a remarkably comprehensive framework. It goes far beyond what I suspect many organizations are currently doing. So, okay, what about the AI providers themselves? What specific responsibilities do they bear, especially when they offer AI as a service, where you're basically consuming their AI models via an API without hosting it all yourself?
Right. AI providers, particularly those offering AI as a service or essentially cloud-based access to pre-trained models or platforms, they carry really significant responsibilities to their subscribers. And these aren't just, good business practices or ways to compete. They are absolutely foundational for building trust, ensuring system integrity, and maintaining security in this rapidly evolving landscape. First and foremost is compliance and audit certification. Providers have to ensure their AI solutions adhere to all the relevant security, privacy, and ethical standards and regulations. Think ISO 2701 for information security or specific industry compliance frameworks. And crucially, they must be able to demonstrate this adherence through independent audits and certifications. It's about verifiable trustworthiness, proving their claims. Next up is robust security. This means implementing strong security controls throughout their entire AI infrastructure, from the data centers right up to the model deployment environment. It includes strong vulnerability management processes, proactively finding and patching weaknesses, and adhering to secure development lifecycles, SDLCs, specifically tailored for AI systems. That means building security in right from the design phase, thinking about AI-specific risks like data poisoning or those adversarial attacks trying to trick the model. A really critical responsibility, directly addressing that black box challenge we keep talking about, is transparency and explainability. Providers must provide clear, accessible documentation. How do their AI models work? What are their known limitations? What specific data sets were used for training, including any known biases in that data? What methods did they use? This lets subscribers, you understand and truly trust the AI's outputs. And critically, it helps you meet your own regulatory obligations for explainability. Related to that is model development. Providers are responsible for sticking to ethical frameworks and secure coding practices throughout the entire development lifecycle of their AI models. This includes building in mechanisms to mitigate bias, ensure fairness in decision-making, and prevent the model from being misused, say, to generate harmful content or facilitate discrimination. Data privacy is absolutely paramount. They have to implement strong data protection measures, ensuring data minimization, only collecting data that's absolutely necessary for the AI's function. Secure, compliant handling of all data, especially sensitive or personal information, throughout the entire AI lifecycle. This covers secure storage, transit, processing, all in line with global privacy regulations like GDPR. Vulnerability management is an ongoing thing, going beyond traditional software. Providers need robust systems, dedicated teams to proactively identify, assess, and patch vulnerabilities unique to AI systems, not just on a schedule, but continuously as new threats like novel adversarial attack techniques emerge. Effective incident response planning is also non-negotiable. They must develop clear, well-defined, effective incident response plans specifically for AI-related incidents, model failures, data breaches from AI systems, successful adversarial attacks. This has to include clear communication protocols with subscribers like you, ensuring timely notification and collaboration during a crisis. Model validation is key to performance and ethics. Providers must conduct rigorous, continuous testing and validation. Ensure the AI models are accurate, fair, reliable, and perform as expected under different conditions. This helps prevent issues like model drift, ensuring consistent, trustworthy performance. Crucially, they must practice strong supply chain management themselves. They need to assess the security posture of their own vendors and manage risk within their broader AI supply chain. That includes everything from where they get their training data to data annotators, open source components they use, the underlying cloud infrastructure. If their supply chain is compromised, your AI solution is compromised. And finally, identity and access management. Essential. Implementing strong controls to make sure only authorized individuals or staff, approved subscribers like you, can access the AI systems and the sensitive data they process. This often means fine-grained access controls, ensuring users only get access to the specific AI capabilities and data they need for their jobs. These responsibilities, taken together, they form the bedrock of a trustworthy and secure AI ecosystem.
That's an incredibly detailed list of expectations for providers.
Yeah.
But okay, it's not just the external providers, right? It's also the internal team, our own employees, people interacting with these systems every single day. What new or maybe enhanced responsibilities do employees within an organization have when that organization adopts AI? It sounds like there's a significant shift in internal roles happening too.
That's a critical point, absolutely. And leads us to think about, well, how do we prepare our own people for this new paradigm? When an organization integrates AI systems into its operations, its personnel, yeah, they take on distinct new responsibilities. These go way beyond just learning to use a new software tool. It's absolutely crucial for the organization to invest heavily in educating and training employees on how to effectively and importantly, responsibly interact with AI. And this training, it isn't merely about operational usage, clicking the right button or typing a prompt correctly. It's about fostering a deep understanding of the AI system's capabilities and, critically, its inherent limitations. Employees need to know precisely what the AI can do, but just as importantly, what it cannot do or where its accuracy might be iffy. For instance, if an AI is designed to analyze market trends, employees need to understand it might not account for sudden, unpredictable global events. Just doesn't have that context. They need to recognize its potential biases, understanding that AI can reflect and even amplify biases present in its training data. And they need to be acutely aware of how the system might be misused, whether unintentionally, through just naive over-reliance on its outputs, or maliciously, through things like prompt injection attacks, where users try to trick the AI into revealing sensitive info or generating harmful stuff. Moreover, employees need to be acutely aware of the broader ethical considerations involved in AI deployment and use. This includes understanding principles like fairness, accountability, transparency, as they apply to their daily tasks. It's about ensuring responsible interaction and decision-making, where the human in the loop understands when to trust the AI's recommendations, when to question them, and importantly, when to override them based on ethical guidelines, company policies, or just plain common sense. This requires a cultural shift, definitely, and a significant educational investment. Empowering employees to be informed decision makers, active participants in validating AI outputs, they become that crucial last line of defense, really. Unlocking AI's true potential while actively mitigating its inherent risks within the organization.
That makes a lot of sense. The human element is key. So we've talked about vetting vendors, training our own people, but what about the practical challenges of actually bringing these new cutting edge AI systems into existing environments, especially when legacy systems are involved? What kind of integration risks should we anticipate when we're trying to connect a sophisticated AI with, say, a system that's been chugging along for 20 years and was never built with AI in mind?
By integrating new AI systems with an organization's existing, often complex, sometimes quite old, legacy infrastructure. They can introduce substantial and unique risks. It's rarely, if ever, a simple plug-and-play scenario. You're dealing with potential issues with data consistency, for starters, ensuring that the data flowing between the new AI and the old systems is accurate, uniform, interpreted correctly across different formats, different standards. Just imagine trying to feed a modern AI model historical customer data from some decades-old mainframe. The data might be structured completely differently, use outdated codes. That leads to misinterpretations by the AI. There are also significant challenges in system compatibility. Older systems just may not have the necessary APIs, those application programming interfaces, the connectors, or the processing power, or even the architectural flexibility to seamlessly talk to modern AI applications. This can lead to potential performance degradation. Either the legacy system bottlenecks the AI, slowing it down, or the AI's computational demands just overload the older infrastructure, slowing everything down. And crucially, new security vulnerabilities can emerge. Due to unforeseen interactions between these disparate systems, or weaknesses in the integration points themselves, each interface becomes a potential new attack vector, a doorway a bad actor could exploit if it's not rigorously secured. And finally, there are significant intellectual property IP concerns. If sensitive data or proprietary models aren't properly secured during transfer or processing between these systems, you need to make sure the AI doesn't inadvertently expose or misuse valuable IP that might be embedded in your legacy data. So to address these multifaceted challenges, our source material outlines several key proactive actions organizations should really undertake. Firstly, fostering stakeholder collaboration is paramount. You need to work closely with all relevant stakeholders, IT, security, business units, legal, operational managers, to fully understand the current state of existing systems and to find a clear, shared path forward for integration. Get that buy-in and alignment right from the start. Secondly, conducting a thorough AI suitability assessment. Is adopting this particular AI solution truly appropriate for your specific needs? Given your existing infrastructure, data availability, the complexity of integration. Sometimes, honestly, a non-AI solution or maybe a different AI approach might be more suitable if the integration risks are just too high, or the ROI doesn't justify the massive effort. Thirdly, comprehensively assess the data governance impact. Understand precisely how the new AI will affect existing data governance and management processes. This means rethinking data ownership, ensuring data quality, setting up new access controls specific to the AI, adapting data retention policies for AI-generated data. For example, will the AI need access to sensitive customer data? How will that be managed securely? Fourth, perform a detailed process and information flow analysis. Analyze exactly how the AI will integrate with and potentially alter existing business processes and information flows. This helps spot bottlenecks, redundant steps, new security requirements. It's about mapping out that entire operational journey to see the ripple effects of integrating AI. Fifth, define a flexible methodology for integrating AI, especially when you're modernizing large data sets. Given how dynamic AI is, an agile, adaptable approach is often much more effective than rigid, old-school waterfall methodologies. It allows for iterative adjustments, learning as you go. You need to be able to pivot quickly. Sixth, accurately perform resource estimation. Meticulously estimate the effort, the planned duration, the financial resources, and the required expertise, both AI specialists and legacy system knowledge needed for successful integration. Underestimating these. That leads to project delays, cost overruns, potentially project failure. And finally, establish robust support processes. Define clear, comprehensive processes for ongoing support across the entire enterprise, covering not just the AI system itself, but also its intricate interactions with all those integrated legacy systems. This ensures long-term stability, operational continuity, and the ability to address issues promptly as they arise. You don't want the AI becoming some isolated, unsupported island within your infrastructure.
This whole discussion really paints a picture of a far more complex AI software supply chain than maybe we initially imagine. It's not just a simple linear flow from raw material to product like in manufacturing. Can you describe what that actually looks like? How does it fundamentally differ from, say, more traditional software supply chains we're used to?
You're right. The AI software supply chain is indeed far more intricate, far more multidimensional than a traditional software supply chain. It's not just about, writing code, compiling it, shipping a binary. No. Instead, it involves this vast interconnected web of complex components, human elements too, that are constantly evolving and interacting. It includes not just the algorithms and models themselves, but also the massive, often proprietary data sets used for training them. The underlying hardware infrastructure that powers all these computations, specialized GPUs, things like that. The various software platforms, from operating systems to specialized AI frameworks. And the entire AI development and deployment infrastructure. It really is a whole ecosystem. Our source material offers a brilliant breakdown that really helps visualize this complexity. It categorizes the AI supply chain into 5 core interdependent dimensions. First, people. This dimension covers everyone involved in the AI lifecycle, start to finish. Data architects designing data flows, developers and data scientists building and refining models, regulators setting ethical and legal boundaries, and users interacting with the AI daily, various vendors providing specialized components or services, and subject matter experts bringing that crucial domain knowledge for effective AI development. Each of these human elements introduces potential risks and responsibilities, human error, insider threats, you name it. Second, processes. These are the structured activities performed throughout the AI lifecycle. This covers governance frameworks dictating how AI is managed, secure development lifecycles, SDLCs, tailored for AI, meticulous data management practices, collection, cleaning, labeling, versioning, rigorous testing protocols for models ensuring accuracy and fairness, continuous monitoring of AI performance in real time, and those integration processes bringing AI into existing systems. Each process point, if not managed right, is a potential vulnerability. Biased data labeling, a flawed deployment pipeline. Third, technology. This refers to the huge array of tools and infrastructure used. Cloud services for scalable computation and storage, communication networks carrying vast amounts of data, specialized hardware like GPUs and TPUs, optimized for AI, operating systems, foundational software platforms, specialized AI infrastructure components, enabling everything from model training to large-scale deployment. The security and resilience of each of these tech layers is absolutely crucial. A compromise in any one can impact the whole chain. Fourth, data. Arguably the most critical dimension, often overlooked in traditional supply chain talk, yet it's the absolute lifeblood of AI. It includes raw data sets for training, vast data lakes for storage and prep, and the trained model data itself, which holds the learned patterns. The quality, integrity, privacy, security of this data at every stage collection, processing, labeling, storage directly impacts the AI's performance, its fairness, its overall security. If your data is biased, corrupted, or exposed, your AI probably will be too. And finally, the model dimension. This represents the core AI artifacts themselves, the specific algorithms use neural networks, decision trees, etc. Computer vision components for image recognition. Deep learning models. Natural language processing (NLP) models that understand and generate human language. These are the intellectual property at the heart of the AI solution. Their integrity, security, ethical alignment are paramount as they ultimately dictate how the AI behaves and what impact it has.
That breaks down the internal dimensions brilliantly. And then our source materials, artificial intelligence relationship ecosystem diagram, that really zooms out, doesn't it? It shows the sheer scale of interconnectedness beyond just these dimensions. It feels like this ever-expanding web of dependencies.
It truly does. That diagram, it illustrates the vast, often hidden, and profoundly interconnected network of entities that contribute to even a single AI solution. It helps you visualize just how many different organizations and components are involved before an AI system ever reaches an end user. It reveals this complex web of trust and dependency. So you have the AI developer at one end, maybe the company creating the final AI product or service, could be internal or a specialized firm. This developer often interacts directly with AI providers, established companies like OpenAI or Hugging Face, providing foundational models, pre-trained LLMs, specialized platforms, often accessed through an API. But these AI providers, they don't operate in a vacuum. They, in turn, rely heavily on cloud infrastructure. Giants like Microsoft Azure, AWS, Snowflake for data storage, massive compute power to train their models, the scalable infrastructure to deploy them globally. And these cloud providers and the AI providers themselves are fundamentally dependent on a deep, complex hardware supply chain. Critical chip manufacturers, NVIDIA for GPUs, Intel for CPUs, TSMC fabricating the advanced semiconductors powering everything, Western Digital for storage. You even have companies like ASML providing the highly specialized lithography machines essential for chip manufacturing, right at the foundational layer. It highlights these incredibly intricate dependencies. Beyond hardware and cloud, you often have specialized software providers, SAP for enterprise resource planning, maybe Cloudflare for network security, who provide critical components or services the AI solution integrates with. And don't forget the sort of unsung heroes, often dedicated data annotation companies, absolutely crucial for labeling and preparing those vast raw data sets needed to train AI models. This manual process ensures the AI learns from structured, categorized info. Any bias or error introduced here can just propagate right through the system. What's truly fascinating here is how all these intricate relationships, from component manufacturers like ASML way down at the bottom, to data annotators, cloud providers, AI model providers, all contribute to the final AI solution you ultimately deploy. Understanding this entire multi-layered ecosystem is absolutely paramount for effective risk management. It allows you to make truly informed decisions. Who should we engage with? What level of due diligence is needed for each layer? How do we ensure the integrity, security, ethical alignment of the entire solution? It highlights the vast attack surface and the profound need for due diligence at every single layer of that supply chain. Because of vulnerability, a misconfiguration, a compromised entity anywhere in that chain, it can impact your final product and expose your organization to significant risk. It's a chain of trust, really, only as strong as its weakest link.
Wow. Given this constantly evolving landscape then, with new AI models, new technologies emerging almost daily, it feels like, what are the evolving best practices for just keeping pace, for effectively managing AI in this incredibly complex supply chain? It really does feel like a moving target.
It absolutely is a moving target, which means continuous monitoring and adaptation aren't just best practices, they're non-negotiable necessities. Our source material outlines several key emerging best practices that organizations really should prioritize to keep pace and manage AI effectively in this supply chain environment. First, you must choose the right LLM monitoring metrics, especially for large language models, LLMs, the powerful AI behind chatbots and the like. It's crucial to identify and track metrics that truly reflect their capabilities, performance, potential impact. This goes beyond traditional IT metrics. You need to look at things like perplexity, how well the model predicts text coherence, does the output make sense? Relevance, is it actually helpful? And safety metrics, is it generating toxic, biased, or harmful stuff? These metrics help you understand not just if the model is running, but if it's running well and responsibly. Second, set up effective logging, alerting, and monitoring systems. Implement robust systems. Combine comprehensive visibility into AI operations with responsive technologies. This includes defining clear thresholds for acceptable performance or behavior. For example, if your AI customer service bot suddenly starts giving rude answers, you need an alert immediately. You also need proper incident response and mitigation procedures for issues like prompt quality, detecting those prompt injection attempts, output relevance, unexpected shifts in model bias, changes in sentiment, detecting toxicity or harmful content. You need to know when the AI is off track or being misused and have a plan. Third, run adversarial tests. This is about actively playing offense against your own AI. Proactively subject your AI systems to rigorous adversarial testing. Intentionally try to trick or manipulate the AI. Identify vulnerabilities, uncover hidden biases that regular testing might miss, assess its robustness against malicious inputs. For example, can you subtly change an image to fool a computer vision AI? This helps ensure the AI is resilient and secure in the real world, not just in a lab. Fourth, work with external and internal AI standards. Integrate adherence to both industry standards for AI, like those from NIST or ISO, developing guidelines for AI trustworthiness and risk management, and your organization's own internal standards for data quality, security, ethical AI principles. This gives you a clear, consistent baseline for responsible AI development and deployment across your whole enterprise. Fifth, never stop testing. Don't assume the model is done after deployment. AI models can experience model drift over time. Performance degrades, biases emerge because real-world data changes. Continuous, ongoing testing is absolutely essential to ensure output accuracy, prevent drift, maintain reliability, and fairness. It's an ongoing commitment, not a one-time project. Sixth, perform a sanity check. Implement quick, straightforward, maybe automated tests of inputs, outputs, overall model quality. Simple sanity checks can often flag major issues or anomalies early before they escalate. Think of it as a quick, are you still working correctly? Check, maybe multiple times a day. Seventh, build and buy wisely, then fine-tune. Make strategic decisions. Do we develop AI solutions entirely in-house? That takes huge resources expertise. Or do we acquire them from external vendors? Often, a hybrid approach makes sense. Once acquired or built, leverage fine-tuning. Customize these models with your specific data. Optimize performance for your unique use cases. This lets you tailor a general model to your specific business needs, often more cost-effectively. And finally, prioritize use with resource constraints. Deploy AI solutions cost-effectively. Optimize for resource constraints, compute power, storage, especially considering the often significant costs of querying and deploying large-scale AI models. This ensures AI adoption is sustainable, scalable, delivers measurable ROI, rather than just becoming a financial black hole. These practices collectively underscore the dynamic nature of AI security and the profound need for ongoing vigilance and a flexible approach.
Okay, now that we've truly delved into the theory of AI vendor management, the intricacies of the supply chain, let's bring it all together. Let's look at a practical example. We have a case study from our source material involving a marketing company. They're named Lister, Rimmer, and Cat's Pattern, or LRC for short. What's their situation? What are they trying to achieve by bringing AI into their business?
Right, so LRC. They're a well-established marketing company. They do branding, advertising, website creation for a pretty diverse client base. They're looking to enhance their value proposition to clients and, importantly, generate entirely new revenue streams. It's a competitive market, right? To do this, they're looking to integrate a cutting-edge AI solution called Red Dwarf Social. It's being developed by a relatively new tech startup. This AI's main function is to gauge public opinion's attitudes by intelligently scraping social media content, processing it, providing sentiment analysis, which sounds incredibly useful for crafting highly targeted, effective marketing campaigns for their clients. So LRC's challenge is to successfully leverage this AI for added value, making sure it's secure, reliable, compliant with privacy rules, and actually delivers on its promise. And this immediately brings up all those vendor and supply chain considerations we just spent time discussing, puts them right at the forefront of LRC's strategic decision-making. They really need to get this right from the start.
Yeah, this sounds like a really common scenario for many businesses right now. So the first question LRC faces when evaluating Red Dwarf Social is a critical one for any new tech adoption, really, it asks. What are some initial questions they should ask? The source material gives us a few options. Option A, immediately press Red Dwarf for details on how their AI actually learns and makes decisions. Option B, focus on market research, interview clients about their interest in this new service. Option C, hire a dedicated AI specialist right away to oversee the AI model's performance. And option D, review their internal risk appetite and tolerance levels for AI. Given everything we've just discussed about AI and its unique risks, what's the absolute first most critical step here for LRC?
Right, it's a classic dilemma, and it leads us to that critical question. What's the foundational knowledge you absolutely need before anything else can really proceed safely and effectively? The manual's answer, and I agree, the most critical initial step is unequivocally A, asking Red Dwarf for information on how the AI model is trained and makes decisions. Transparency and explainability. They're absolutely paramount for ensuring fair, accurate, secure AI outcomes. Without understanding the model's inner workings, its training data sources, its algorithms, its decision logic, how it handles different inputs, LRC just cannot properly assess its risks. They can't guarantee its quality, ensure its ethical behavior, or even verify it will provide the value they promise to their clients. This foundational understanding allows all the subsequent assessments to be truly informed and meaningful. Let's quickly look at why the others, while important, aren't the initial critical step here. Option D, reviewing risk appetite. Yes, important, but it comes after you have some initial understanding of the solution you're evaluating. You need to know what risks the AI introduces before you can define your appetite for those specific risks. Makes sense?
Yeah, that makes sense.
Similarly, options B and C are either premature or supporting roles. They come into play once you have that foundational knowledge and deem the solution potentially viable. Interviewing clients B is market validation, understanding demand. Crucial for business, sure, but it doesn't address the underlying security or operational risks of the AI itself. And hiring an AI specialist for oversight. Excellent idea, eventually. But it presumes you already have a basic understanding and confidence in the core AI solution that warrants bringing in external expertise for ongoing monitoring. So understanding the model's mechanics, its inputs, its decision processes, that's the indispensable first step. Ensuring the AI provides genuine value, meets your security and ethical standards, and doesn't introduce unforeseen liabilities. You simply can't assess what you don't understand.
Okay, so LRC follows that advice. They ask Red Dwarf for information, but they discover the model is, as we've discussed, a black box. Its internal workings aren't transparent. This is a really common and significant challenge, especially with proprietary AI from startups guarding their IP. Given this opacity, this lack of transparency, what actions can LRC take to address this limitation? To help disclose information on how the model performs, even if they can't see the code inside, the options presented are A, rely on existing information security policies. B, gather technical information on the AI models. C, collect stakeholder feedback. D, look at financial projections.
Yeah, this highlights that very common, very difficult black box problem. You know what goes in, you know what comes out, but you don't know how the AI got there. In this scenario where the internal workings are opaque, both B, technical information on AI models, and C, stakeholder feedback, are critical. And actually, they're highly complementary actions for LRC to take to try and shed some light on its performance. Let's look at the others first. Existing InfoSec policies, option A. Important, yes, they need adapting for AI, but they primarily provide a framework for how you operate securely. They don't inherently reveal the model's performance or help understand its specific behaviors when you can't see inside. Foundational, yes, but not the direct solution to transparency here. Financial projections, option D. Crucial for business strategy, viability, sure, but they don't help understand model transparency or performance at all. Different purpose entirely. So technical information on AI models, option B. Even if Red Dwarf Social is a black box, LRC can still ask for and potentially get valuable insights. This might include details on the type of model it is, maybe a deep learning neural network, an NLP model, its general architecture, even if not the exact weights. The nature of its training data sources, volume, demographics, any known limitations or biases in that data. Performance metrics from Red Dwarf's own testing accuracy, precision, recall. How it handles various inputs, edge cases. This technical info, even if it's high level, can give LRC's security team, maybe any AI specialist they bring in, crucial insights into its expected operation, potential vulnerabilities, likely behavior. It's about getting any available data to understand the black box's characteristics from the outside. And simultaneously, stakeholder feedback, option C, is immensely valuable. It provides real-world operational transparency. This means gathering input from various groups who will interact with or be affected by the AI. LRC's internal marketing teams, their actual clients who will consume the AI's output, maybe even compliance or legal teams. Their feedback on the AI's outputs is the sentiment analysis accurate for sarcasm. Does it show bias for certain demographics? Is it useful? Understandable. That provides real-world, observable insights into its functionality, its potential issues, even when the internal mechanics are hidden.
It's like seeing how it performs in the wild.
Exactly. If users consistently report the AI gets sarcasm wrong, that's crucial feedback on performance and potential bias, even without seeing a line of code. So it's about gathering every piece of available data, technical characteristics, and experiential observations to glean insights into this opaque system. Build a more complete picture of its operational reality and its risks.
That's a great approach, combining what you can learn technically with those real-world observations. Okay, finally, let's consider the bigger picture for LRC. They have a draft AI lifecycle program in place now. Their CISO, the Chief Information Security Officer, needs to review their existing cybersecurity program, see what can be adapted, what needs entirely new focus to handle AI risks, what specific areas are most relevant to AI that they should prioritize and adapt their current cybersecurity program for. The options given are A. Data loss prevention strategies. B. Legal and regulatory considerations. C. Data privacy and security considerations. D. Integration with legacy systems.
Right, this is where the rubber really meets the road, isn't it? Applying these AI principles to existing security frameworks. And our source material indicates very clearly that all of these areas are not just relevant, they're critically important for AI security. Each one requires specific and thoughtful adaptation. It's not about choosing just one here. It's about addressing all of them as interconnected components of a truly robust AI security posture. Let's break it down quickly. A. Data loss prevention strategies, DLP. Yeah, similar role to conventional IT security, stop sensitive info leaving your control. But for AI, these strategies must be profoundly adapted. Think about the unique ways AI processes, stores, and even generates data. Sensitive customer data used for training. It could inadvertently be leaked or inferred through the model's outputs later on, or the large, valuable training data sets themselves become prime targets for theft. So traditional DLP tools. They need reevaluation, reconfiguration to understand AI-specific data flows, potential data embedded within models, the risks with AI-generated content. B. Legal and regulatory considerations. Absolutely paramount and continuously evolving, probably faster for AI than anything else recently. Laws around AI ethics, human rights, data governance, accountability for AI decisions, they're changing rapidly differently in different places globally. Think about the EU's AI Act, classifying AI by risk level, imposing strict rules for high-risk AI, or the right to explanation under GDPR for automated AI decisions. Organizations must stay on top of these developments. It directly impacts deployments. Non-compliance can mean huge fines, legal challenges. Compliance here isn't just avoiding penalties, it's about building trust, showing responsible innovation. See data privacy and security considerations. Exceptionally crucial with AI. AI models often rely on vast, diverse data sets for training and inference. That significantly increases the scope, the complexity of privacy and security risks. Personal data, sensitive health info, financial data, IP can all be embedded in or processed by these models. Ensuring data minimization, only collecting what's needed, robust anonymization, secure data handling through the whole lifecycle, stringent access controls. It all becomes even more challenging, more critical in an AI context. Imagine the fallout if an AI processing medical records accidentally re-identified patients, or a facial recognition AI database was breached. And D, integration with legacy systems. A very practical, often complex challenge, as we discussed earlier. Connecting new AI solutions with older, entrenched systems can introduce new vulnerabilities, compatibility issues, create complex interdependencies needing careful management, continuous monitoring, ensuring secure, efficient data flow, managing different data formats, maintaining stability between these disparate systems. It's a major undertaking. It can open up unexpected attack vectors or create huge performance bottlenecks if not handled right. So, just to reiterate, each of these areas needs specific, tailored attention. You have to adapt existing cybersecurity programs for the unique risks and requirements AI poses. It really underscores a comprehensive, holistic approach needed for AI security. It's recognizing that AI doesn't just bolt onto existing systems. It fundamentally reshapes the entire security landscape. It demands proactive, multifaceted engagement across the whole organization.
We've truly taken a deep dive today. Wow, from that high-level understanding of AI's growing role in the supply chain, right down to the granular responsibilities of providers, employees, and even dissecting that real-world case study with LRC. It is abundantly clear, isn't it? Managing AI goes far, far beyond traditional IT security checklists. It requires a much more nuanced, dynamic, forward-looking approach.
Indeed. And if we connect this back to the bigger picture, I think the key takeaway is just that the rapid evolution, the pervasive integration of AI across industries, it demands constant vigilance, profound adaptability, a really proactive approach to risk management. It's no longer sufficient to just react to threats. Organizations have to anticipate them, design for them right from the outset. This is fundamentally about building trust in AI systems, ensuring transparency even when dealing with complex black box systems, and continuously assessing how AI impacts every facet of an organization: operations, security, ethics, human capital. Like you said, this isn't a one-time project you check off. It's an ongoing journey: learning, adaptation, continuous refinement. demanding collaboration across multiple domains within the enterprise. It's a fundamental shift in how we approach technology risk.
So, what does all this mean for you listening as AI continues to become even more integrated into every aspect of our lives, our businesses? Maybe consider this. What new opportunities or perhaps unforeseen risks might emerge as these AI supply chains become even more interconnected, more globalized, maybe crossing more borders, more regulatory frameworks? And how might that impact your own role or your industry in the very near future?
It's a fascinating challenge, really, and one that's only just beginning to unfold.